Hi guys, welcome back for Unit 7 with Mrs. Matheson. We're going to be doing Notes 1 today, which is on Fundamental Counting Principle. Our learning target today is I can use the Fundamental Counting Principle to determine the number of outcomes for a given situation. So let's talk about, well, what is that Fundamental Counting Principle? Well, we're going to start with an example, and that's going to lead us into it. It says, at a cafeteria, you have several options for a sandwich. You can choose either white or wheat bread. You can choose turkey, ham, or roast beef. You can also choose cheddar, American, and provolone cheese. Construct a tree diagram to represent a number of different possibilities for your sandwich, assuming you select one item for each category. So you could sit down, you could list out, and you could say, I'm going to have white bread with turkey, with cheddar, and then you can go through and go, I'm going to have wheat bread with ham and provolone, or we can make this into an organized diagram. We can start off by choosing white bread or wheat bread. With each of those choices, we could choose turkey, we could choose ham, or we can choose roast beef. I can also choose that with wheat bread. Turkey, ham, or roast beef. Then I could choose white bread with turkey, and then from there I could choose cheddar cheese. I could choose American, or I could choose provolone. I could also choose white bread with ham, and then I have my same three choices for cheese. And then with roast beef, I have the same three choices for cheese again. Then I also have those options with wheat. I can choose wheat bread with turkey, and we can choose, we're going to run out of space a little bit, cheddar with American or provolone. I could make those three choices with ham, cheddar, American, or provolone. I can make those three choices with roast beef, cheddar, American, and provolone. So it says that's to construct the tree diagram. So I just want to talk about how many choices we possibly could do. We could have white bread with turkey with cheddar. We could have white bread with turkey with American. We could have white bread with turkey with provolone. So that is representing these three sandwich choices right here. I also could do that with white with ham with cheddar, white with ham with American, white with ham with provolone. So that is our next section, or we could choose white with roast beef with cheddar, white with roast beef with American, or white with roast beef with provolone. So just choosing white bread, counting those up, I have 9 choices just with white bread. So if we also include wheat bread, we have 18 choices. 18 choices. This is a tree diagram representing that. All right, so this represents that outcome. And so we want to talk about a tree diagram is a diagram used to show the total number of possible outcomes. Then sample space. Sample space is the list of all the possible outcomes. So that was this list that I was working on right over here. This isn't all of our sample space. If we'd include the other ones, that's our sample space. Then last, we also have event. It's the collection of one or more of the outcomes. All right, so talk about fundamental counting principle. Hey guys, remember, don't forget to pause or rewind if you missed any of that. Fundamental counting principle is if one event can occur m ways and another event can occur n ways, the total number of possible ways for the two events to occur is m times n. So that's only for 2 events. If we have more than 2 events, maybe the first one has m outcomes, and the second one has n outcomes, and then the third one has p outcomes. We would multiply all those together. Fundamental counting principle is one that you're going to use when you're given choices. So if we look here at our first example, it says Farmington High School soccer team has orange, white, and black jerseys. The team uses orange or black pants and black or white shoes. So use the fundamental counting principle to determine the number of uniforms they can wear. So here we have choices, okay? So we have our jersey choice. we have our pants choice, and then we have our shoe choice. So we have choices for our jerseys, orange, white, and black jerseys. So we have 3 choices here. Remember, we're going to multiply our choices. We can choose orange pants or black pants. So we have 2 choices for pants. And we can have black or white shoes. So we have 2 choices for shoes. So if we multiply those, 3 times 2 gives us 6 times 2. We have 12 uniform choices that we can choose from. All right, you're picking out a new car for your 16th birthday. Woohoo! You have a choice of 7 exterior colors, 8 interior colors, and 4 fabric choices. How many different possibilities of color and fabric choices do you have? I'm confident that you guys are going to be able to figure that out. All right, so let's talk about counting arrangements. This is a slightly different. Student council has a president, a vice president, a treasurer, and a secretary. For a school assembly, they're all required to sit in a row upon stage. In how many different ways can we arrange themselves? So here, we are now talking about an arrangement. The counting principle, the last few problems we've looked at, we had choices. We can choose from different things. Here, we also have choices, but they need to be in a specific order. So if we have a president, vice president, treasurer, and secretary, we have 4 people to choose from. So for that first chair, there are 4 people to choose from. But when you get to your second chair, you no longer have one of them because they're sitting in the first one. So now we only have 3 choices to choose from. Then for your third chair, you only have 2 choices to choose from. And our last chair, we only have 1 choice to choose from. Again, just like our fundamental counting principle, we're going to multiply all of those. So 4 times 3 gives me 12, times 2 gives me 24, times 1, there are 24 different ways that we can sit 4 people in a chair. So this, what you see right here with this counting arrangement, is actually leading to a special math term. And we call that a factorial. And that's that little exclamation point that it means factorial. So this reads n factorial. It's the product. We want to think product. Product means multiply or multiply. Okay, of all of the positive integers beginning with n and counting backwards to 1. So if we look back here, we had 4 times 3 times 2 times 1. That is an example of factorial. So we could have simplified 4 times 3 times 2 times 1 into 4 factorial. When you guys come to class next, we are actually going to talk about how we type that into our calculator because we actually have a button for that, so that's pretty nice. And then I want you guys to try to write out the values for 5 and 6. So show me, what does 6 factorial look like? What does 8 factorial look like? And then you guys can calculate those, and we'll talk about those buttons in class. We'll see you guys then.